The next topic for this playlist, analytical approaches to modern geometry, is the idea of the foot of perpendicularity, or the foot of the perpendicular. Now, this is actually the common point or the intersection point of two perpendicular lines, and we call it the point of perpendicularity, but this time we're going to consider it as foot of the perpendicular, as we had the relationship of a line. Let me draw here a line. Okay, let's say for example, I have here a line. Okay, that's a line. And I have here a point, not on the line. Let's say this point here as, let's say, point X. And this, of course, represented by any equation. Usually, we have here L is equal to P plus your vector V. The point of perpendicular, or the foot of perpendicular rather, is the intersection, or the point that will connect the point X to the line at the smallest distance, right? We know that in our high school years, the smallest distance. So say for example, if I'm going to draw here a line like this one here, and it is the smallest distance from that point to this line, assuming that I have it as well in perpendicular form. So let's say this perpendicular form. This is our point F, the foot of perpendicularity, or the foot of perpendicular. And this time, in the usage of the concept discussed in this playlist, we are going to determine the formula, or we're going to discuss rather the formula in solving for this foot. In our high school years, what we usually do is actually get the slope of this line. Okay, and then since we are thinking that the line that will pass through the point X in the foot of perpendicularity is a perpendicular line, so we transform that into if m sub 2, which is again we know as the negative reciprocal, right, of m sub 1. And then with this slope now and the point X, we can actually determine the equation of a line. Yes, that's what we do in our high school years. And then since we now know the equation of the line of this original line, and then the equation of the line of the second line using the slope and this point, we will have its intersection. Solving for two equations, we can get their intersection. That's actually the foot of perpendicularity, the foot of perpendicular line. This time, in the concept of the analytical approaches to modern geometry, we can actually structure it in simpler form, as long as we use and we know how to use vectors and normal vectors. The formula is indicated in this manner. The foot of perpendicular is the point X identified minus the inner product of X minus P, where P is any point on the line. Okay, so it considers any point on the original line. And then you have here your normal vector. The normal vector of your in comparison to the direction vector of your line, but this is actually in unit form. Okay, so I'm going to take note of this. X is the point, not, let me do it here, not on the line. Okay, so we have here P is any point except the foot on the line. They have here your N is, of course, your is normal vector, but we are using N sub U. We have here is the normal the unit normal vector. Unit normal vector. So again, in the process in our high school years, we can determine this intersection by first, we know the equation of this line. Next, solve its slope. Then, solve the slope of the line perpendicular to it. Using this slope and this point X given, you can actually give the equation of the perpendicular line. And using the equation of the perpendicular line and the equation of the already identified line, we can solve the point of intersection by elimination, by substitution, or by graphical representation. And that is actually the point here. But for the topic here in analytical approach to modern geometry, we'll be using these notations. We'll be using the concept of the normal vector, or specifically the unit normal vector. And then we have a point, any point on that line. It may be here or there, as long as it's not the foot. And you have here your X, which is the point not on the line. We'll have some examples to this as we move forward to this topic. Thank you very much for watching.